Okay, we're picking up from where we left off yesterday. We were doing the matching. And it so happens that we went through the ones that were more complex first of all. And so now we take, so we finished with I yesterday, and so we're here at J. What do you think for J? Okay, decreasing, slope is negative. So you're going to look for this piece from here to here to be negative. Where do we see this piece from here to here negative?
9.
Okay, 9 looks like that could be it. Let's go test it. So that's a good thing. And so we're positive from here to here. Does that work out? Yeah. And then we should be negative from here to here. So to me, 9 is looking good, right? Yeah, I'm going to tell you this is a specific one that I'm going to talk about here. K. So now, so we are positive on this interval here, and negative from here to here. Where is that going to be? Where do we see positive right at beginning, and then negative from here to here? Where do we see it start out positive from here, but negative from here to about here? 14? 14, yeah, that's probably the only one, right?
Yeah.
Let's put 14 here. Then L, we have this thing negative all the way, and looks like approaching 0. So negative all the way, but approaching 0 when we get right here. So maybe it'd be 0 about right here, but mostly negative. Where do we see that happen? Negative all the way from negative infinity to right here, but just about 0. Where do we see that happen?
I need to cross off all the ones we've already done. I'm confusing myself.
4, you think 4? Because 4 is negative, right? And approaches 0 about right here. So I'm thinking 4 looks pretty good.
Yeah.
And then M, so we're positive all the way, but starting at 0, about 0 here, but then positive all the way from there is going to be 13. Yeah, I'm going to go ahead and this, and there are really a couple ones that are really good cross-referencing things. Okay, now for N, we're negative all the way to here, but then all of a sudden positive. So negative, boo, 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 all of a sudden positive. And it should be a break. You should see a discontinuity. 15, so negative, all of a sudden, then a break positive. That, to me, that looks good. 15 looks good. And then for this one right here, you have negative, this is negative and negative. So it's going to be negative all the way with maybe a discontinuity here.
So that one would be 6.
Probably 6, yeah. Well, it's going to be 6. So you see once you, and we save the hardest ones for last, really.
Really? Because I was better at those than the easy ones.
What's that? Yeah.
I did that pretty easy.
You did pretty easy.
To me.
It is, but.
I was confused yesterday.
Oh, were you? Okay. Well, I think it just takes some time getting used to it. To me, the first part we did yesterday was easier than the latter part, but that's just me. All right. Now, I want to tell you something. One of the first ones we did today, I think, was J, right?
Yes, that's what we started with.
We started out with J. What happens is this one here might be y equals sine x. And we said this j matches with 9. Well, here's 9. Well, the derivative of sine x, y prime is going to be cosine x. So this is the cosine function right here. Okay? And so that's it. And then the derivative of cosine is negative sine. And then this one here, you notice that m was related to 13. So here's 13. Don't m and 13 look the same? Mm-hmm. Okay, what that is if you have y equals the exponential function e to the x, y prime is also e to the x. So this function has the unique characteristic of the derivative of that function is itself. Okay, period. So so those are two unique little things in these functions. So that's just something to file away in that memory bank as we go forward. We're going to be doing derivatives and so forth. All right. Now we get into the next note card.
Note card 33.
Note card 33, graphing f when given f prime of x. And all these steps, 1, 2, and 3, they are just verbal reenactments of what we've been working with in the number line system all along for the last several weeks now. How long have we been working on number lines? Probably at least 3 weeks, right? 3,
Yeah.
something like that. So to me, this is probably, and it's, if you have that diagram, the f prime, f double prime thing, just makes this thing easy. And also, you have this thing here, right? So I want you to go ahead and for 1 and 2, sketch f of x on the same coordinate plane. Here you're given an f prime of x. Here you're given an f prime of x. What is f of x going to look like?
Oh. So kind of like how we did yesterday?
Yeah, except you're given, yesterday when we set the number line, we were looking at the bottom first and looking what happened here. Here, we're going to be looking at what happens here and then deducing what's happening on the f front. So where do we have our critical numbers?
At negative 2 and positive 2, negative 2, 0.
Negative 2, 0, and 2. So there they are. And so what do you have? What are the signs up here?
Okay. The signs. So from it's decreasing until negative.
Do you see above or below the x-axis? That's all you're looking at.
Above.
So what is this going to be here? What is this piece over here to the left of negative 2? Above or below the x-axis? Above or below?
It's above.
Above. Okay, so we know what is f doing in that interval. Increasing. Above or below the x-axis?
Below.
Below. Above or below?
Below.
Below. Above or below?
Above.
Above. So now we know we have this, we have this, and then we have this. Okay, next thing we do is we take f double prime, and then we put our PPOIs, that's going to be f down here. What are the PPOIs going to be for this?
It's between.
Yeah, right here, right?
It's between negative.
So maybe negative 1.5, something like that.
Would it be again 0?
and 0,
And then positive 1.5?
and then maybe positive 1.5. I mean, that's approximately right. Maybe it's 1.4. We don't know exactly what it is. But, okay, and so now, what are we going to have here? We're going to have, what is this going to be between negative infinity and negative 1.5? Okay, remember, we have
The decrease.
decreasing, right? Decreasing, so we know this thing is going to do what?
Go down.
It'll concave down. And then between negative 1.5 and 0,
Increase.
increasing, so concave up. And between 0 and 1.5,
Decreasing.
decreasing, concave down. And last thing, we have increasing, so concave up.
Whoa.
And so now we have all the pieces that we can use from here, right? And so between negative infinity and negative 2, what do we have? We have positive and negative. Which piece is positive over negative?
The top left.
Top left. So we know that the thing is going up like up until negative 2, is that right? So the thing is going something like this. Okay? It has a concave down shape. It is still increasing. And what happens between negative 2 and negative 1.5?
It's negative.
Negative over negative. So it's going to be this looking piece here, right? So we go over here to negative 1.5. So there it is. We're at negative 1.5. What next? Between negative 1.5 and 0, what do we have?
Negative.
We have negative over positive. What does that look like?
So, up.
This thing here, right? So it's going to come like this all the way to 0, right? So there we are at 0. And what do we have now? Between 0 and 1.5.
Between 0 and 1.5. Negative.
Negative, negative. It's going to be this piece here, right? So negative, negative, we go to 1.5. So something like this. Okay, something like this, all right? And then what do we have from 1.5 to 2?
From 1.5. Oh, wait a minute.
Negative over
Positive.
positive. So this looking piece here, all the way to 2. So we go like this. And what do we have greater than 2? Positive, positive. So that's going to be this piece right here. So there it is. So what I want you to do is go and do number 2. It's a similar type of problem. I don't think there's as many twists and turns in it, but let's do number 2.
I can tell by the numbers.
To me, that looks like, number 2 looks like a cubic. And so the original should be a quartic. It'll either like start high and end high, or start low and end low. And I'm thinking probably start high and end high. Is that what you get?
Mm-hmm. I can't tell where the numbers exactly.
Yeah, let's talk about, so you're talking about the numbers?
Yeah, like, you know.
To me, it looks like there's a critical number
I like
at
it.
maybe 1.8 or something like that. And then your PPOIs look like you have like your maybe negative 0.3 and positive 1.2 or 1.3, something like that. So you have one line with your critical number at 1.8, and then the lower one, you can have your critical numbers here at negative 0.3 and positive 1.3. And then you just construct your intervals like this, and therefrom determine. Now, what you have to do that you're not given, you're not given a starting point. We don't know exactly a starting point. So this curve here, this red one that we drew, could be up here, could be down here. You don't know exactly where it is. And we don't have an exact look at the degrees, and so you're making conceptual drawing more than anything else.
I have what it does, I just have to draw.
Yeah, let's sketch it. So sketch it in first. Best you can, do that.
I'll sketch. Oh, I just stopped myself sketching. It hurts so bad.
I will tell you that what you're learning now to do in class is a thing that it took me some time to catch on how to do it, especially, now this diagram here with the circles, I think this one helped me more than anything as far as understanding how to piece things together.
I like those circles.
Yeah, because it's just, and it's one of those tools, if you just follow it, you're gonna get it right. Okay, and so I see that Kylie is done pretty much, and I think Gavin is, so anyway, we have our two number lines here. For the first one, I'm gonna put F prime and F. For the second one, we're gonna put F double prime and F below here. And it looks like we have a critical number here of about 1.8 or so. And then I'm showing negative all the way from negative infinity all the way to 1.8, and then positive for greater than 1.8, right? And now the critical numbers here are some about maybe negative 0.3 or something like that.
Yeah.
Negative 0.3. And then here, it looks like it's maybe 1.3 or something like that. And then it looks like we're increasing here. So increasing, this is going to be this shape here. And between 0.3 and 1.3, we're looking that that's going to be a decreasing, so that'll be concave down. And then from 1.3 on, it looks like we're concave up again. Does that look right?
That's what I said.
And so now, and we have some pretty tight quarters in here too, don't we? Between little pieces. But we know the first piece is going to be negative over positive all the way to negative 0.3. So what does negative over positive look like? This piece here, right? So we're going to come, I'm going to try to work it above here. And that's all the way down to negative 0.3. So just start like this, and go like this all the way to negative 0.3, so something like that, maybe. And then between negative 0.3 and 1.3, what do we have?
Negative.
Negative, negative, so it's going to be this looking thing here, right? All the way to 1.3. So here's 1.3 over here. So thing's going to go like this. Piece like this. So something like that, right? Does that look about right? Okay, what about between 1.3 and 1.8?
Negative.
Negative over positive is going to be which one? This little piece here. So we have just a negative over positive all the way to 1.8. So it'll be like that. And what do we have for 1.8 on?
Positive.
Positive, positive. So it should look something like that. Does that look about what you have?
Yeah.
What about you, Gab? Does that look about what you have?
No, it isn't.
Did you? Okay. Well, it takes practice. Okay, so just try to look at opportunities, because you can do it with just about any kind of curve. You can visualize, go ahead and do that. So what I want to do is go on to the next section here.
I like doing the curve sketches.
Do you like doing that? Does it kind of bring back your artistic inclinations a little bit?
Yeah, and I like number lines. I don't know, I just like the little circle thing. It's cool.
Yeah, I think it is. I mean, I think that it's amazing that you're able to take the analysis tools and take you someplace. Okay, this is from an actual AP test here.
Oh, scared of those.
And here you have it looks weird. You have this, and this is a graph of F prime, and it's the same thing. So we'll go ahead and Does it say draw? It doesn't. It says find the equation tangent. So let's just go over this. This is a graph of f prime. Define this interval. We have this line. We have this semicircle, and so we have, and it describes here what it is. And so A, on what intervals, if any, is f increasing?
Increasing.
So f is increasing. Remember, you can draw a number line, right? So draw so you can draw a number line. And so if your number line, you can make a number line above here. So you can put f prime and f here. And you can make another number line, which is going to be your f double prime and f, right? So over what interval, if any, where's our critical number on this thing?
Our critical number is -2 and 2.
-2 and 2, right? So let's go to -2 and 2. So over what interval, if any, is f increasing? What do we see? We see positive, negative, that's negative, all the way to there, and then negative here, right? So what interval is the thing increasing?
From -2.
All the way to, so increasing on, the function is defined there. So increasing on -3 to -2, and why is that? Because, what is our justification? Because, where's our justification?
Prime's greater than 0.
Yeah, because f prime is greater than 0. Find the x-coordinate of each point of inflection of the graph of f on the open interval. So where do we have our points of inflection?
2.
2 and here we have 0 and 2, right? 0. And so between infinity, between -3 and 0, we have, okay. Between 0 and 2, we have, and between 2 and 4, we have negative, so we have this. So where do we have, find the x-coordinate of each point of inflection. So POI at x equals 0, x equals 2, and why is that?
The real function.
Yeah, because we use the evidence here because f prime changes from decreasing to increasing or increasing to decreasing. Changes from decreasing to increasing or increasing to decreasing, right? Inc to dec. Find an equation for the line tangent to the graph of f at the point 0, 3. So here at 0, 3, 0, 3, we are right so 0, 3, find an equation for the line tangent to the graph of f at the point 0, 3. What do we have? What do we know at 0, 3? What is our slope? f prime of 0 is equal to what?
Um, 2.
This graph of f prime, what's f prime at 0? This is a graph of f prime, starts here at 1, goes, it'll be -2, right? So now can we draw our tangent line? Yeah, because we have what? We have a point and a slope. So that's going to be y minus 3 equals -2, and we're going to have x minus 0, right? So we're going to have that. We're going to have, we could solve this. We have y equals -2x plus 3, right? So that's going to be our equation for a tangent line. And now it says, now we get into find f of -3 and f of 4, show the work that leads to your answer. For D, what you're having to do is we're having to get into integral calculus.
Oh.
Okay, we're having to integrate to do that. And we did that it was the very first thing we did at the beginning of the year.
Oh, not this very one.
You probably don't remember what it is. We find f of -3. Well, we know that this is 0, this point is 0, 3, don't we? All right? And we know that our slope, okay, what you do, it's going to be a matter of area here. So you have an area here because the thing is going down. So you're looking at the area under the curve. And so you have, we know we have 0, it's 0, 3, isn't it? So we know it's 3 here, and we know we're below the x-axis here. So we're going to have to take the 3, to get here we had to take the 3 and subtract out the area of this and add this area here. What is this area going to be here? 2 by 2.
4.
Yeah, it's going to be 4 divided by 2. So 2, right? So this area is 2. What's this area here going to be? 2, 2, 2. Looks like that's 1/2.
Yeah.
So we have to take this to get from here. So what it is, this is going to be f of -3 is going to be equal to well, we know we had to get here. Let me do f of 2. F of -2 is going to be what?
F of -2?
Because you went down 2, so you probably had to be 5, right? So you had to start at 5, and then we went up 1/2, so this is going to be 4.5. So f of -3 is 4.5, f of -2 is 5. We went down 2, and that's how we got to f of 0 equals 3. And that says find f of 4. How do we find f of 4? What it is, you have this area of the circle. It actually is not the area of the circle, but it's this area here.
Area around the circle?
Area around the circle. So you can have this whole area here, like taken out of the square, and this is going to be subtracted from that. So it's going to be 3 minus this area right here. And that's going to be, what is that going to be, 2 by 4? That's going to be 2 by 4 minus the area. How do we find the area of that? It's going to be 1/2 pi And what is r here?
Oh, radius
Radius
2.
2 squared. So that's going to cancel that. So we're going to get 2 times 4, so it's going to be 8. So it's going to be 8 minus 2 pi. But then, so we're going to have to subtract that. So this is going to be 3. So f of 4 is going to be equal to 3, which is where we started here, minus 8 minus 2 pi. And so that's going to be f of 4. And so really that's it.
Crazy.
Yeah, it's crazy. Now to me,
Pretty cool though.
yeah, it's cool. Now the thing that you have is that what we've done in this class recently, you should be able to do A, B, and C okay. This one here, you sort of have to reach into integral calculus for that. Let's kind of see where we're headed tomorrow before we shut off the camera. So it looks like we have some more things to figure out tomorrow on this next thing, so we will do that.